Here we are. We're back in vectors. I'm on page 2 of the notes, and we're going to basically outline two concepts here. So this particular video is very important. One is called a scalar. And so a scalar measurement, key idea when we're talking about scalars and vectors, both a scalar and a vector are both measurements. So we're measuring something, but it's what we measure that distinguishes that particular measurement from a scalar and a vector. So a measurement that is a scalar, a measurement that describes only the size or the magnitude of the measurement without indicating direction. So for example, if I were to measure, maybe I draw a line on my page, maybe the length of that arrow is 2 centimeters, and I could say, okay, the length of that arrow is 2 centimeters. Notice, I didn't know which way that arrow is pointing. I told you how long it was, how big it was. And when we talk about how big or how long, we're talking about a scalar concept. Here in just a moment. That vector will tell us a little the direction. So here's vectors. Vector is a measurement that describes both the size and the magnitude. That's what we talked about in a scalar. And the direction of the measurement. And that's what makes it different between scalar and makes a vector than a scalar. Vectors have a direction component to them. So on this one, this would be 2 centimeters. I guess you up on the page. So 2 centimeters up. As soon as I, all of a sudden, it's not just a scalar. Now it's a vector. All right, we can show direction with a number of different symbols and concepts. So I'm just going to basically list. We could say up, I just used. We could say down. We could say left. We could say right. We could say north, south, east, west. Any way you show direction. We can actually use direction. We can say positive and negative. Positive being negative down, positive being to the right, negative being to the left. Use arrows. Actions, so arrow written above a vector quantity. So let's say you're going to measure something that's a vector. Then you put an arrow on the top. Sometimes that arrow doesn't necessarily have the second part of the arrow to it, so you can just put a little to it on the top to indicate the quantity. The textbook uses boldface. That's sometimes done. Boldface letters, and I have the textbook here. I'll just show you. This is on page 79 of your text, and you'll notice 79 that this A, B, C, and D are all bold-faced letters, and if we make them, then that distinguishes those measurements from a measurement that doesn't have direction. So let's see if I can find one. This C here isn't necessarily a vector. So it just distinguishes between colors and vectors. So if it's bold-faced in the book, it's a vector. If it's not bold-faced, we can assume that it is a scalar. Our website is called Display Me. You're going to have to attend class to be able to see that one. Julie showed us that one last year. I entered in this year, and as we're going to no video or a demo or an idea that you just ask if it's something that is worthwhile, and I add to the notes for the next year, then I will your contribution to the notes. So there's Juliana's, and she will be in there as well in my notes. Let's go to the unit sheet or the edition sheet. That's your orange sheet. As for the orange sheet, you're going to notice that we show orange or with your equations with arrows, and so there's the arrows right on top of there. So notice that time is not a vector. The A is acceleration, the V, which is velocity, those are all vectors. Be consistent with that throughout the entire worksheet. Another one, if you go down to work, just down below, work doesn't have the arrows, so it's a scalar before displacement. So just a heads up, that's how we're going to show vectors and distinguish distinguish between vectors and scalars on the equation sheet. Example number 1 has us do a couple different things. The first 5 of each unit. So I'll do the first 3 with you and give you a chance to kind of see what to do with them, and then I'll let you do. You can stop the video and then try them on your own, and then it can check out. So this is identify the dimension of each unit. So real numbers out in front are irrelevant, and all that matters is pretty much the unit. So 10 seconds. We know that seconds. About 3 of them. The next one is slug mass. So when here slug's the mass. Degrees Celsius is 10. Kilograms is as well. And then the part of the directions say, then classify each unit of a vector. So when we divide between a scalar and a vector, for it to be a vector, we've got action shown some way, up 8, something. So that's what I'm looking for. So seconds doesn't have any direction to it, so we'll call it a scalar. Slugs, notice slugs doesn't have anything on it, so we'll call it a scalar. Degrees Celsius doesn't have up, down, left, or right, so scalar. Kilogram scale. A couple of vectors that are tucked into this one. Give it a whirl and see what you can get on the video. Here we go. I'm just going to go ahead and write the answers. Meters is distance. Meters left, I'm going to put 2 distance, but better yet, we're going to get to this display. So meters left with the direction is displacement. We'll talk about that in a couple of days' time. Here's another one that's unusual. Meters per second east. Some people at first are going to call that speed, but it's better to call it velocity. And then meters. Plain old meters. This kind of actually displacement. I'll show you here in a moment. All right, on E, if we go back there, there's no direct plane scalar. Meters left. Now the left makes it a vector. It's a vector. Time, it's a scalar. Meters per second is a scalar. There's no direct. As soon as we for letter I assume the word east, that makes a vector. And this one's it's kind of got a little to it. At the word when you the symbol minus out in front, that either it's going to indicate to the left or it's going to indicate that 2 is a vector. So you have to be kind of aware of the minuses kind of floating around there. All right, and the last little bit here is this last little bullet, and that would be motion. Motion is anytime you change your, and there it is, scales